You're welcome back from break. Let's continue from where we stopped. Here we come to another concept, yet under coordinate geometry. The concept is equation of a line passing through 2 points. Don't forget, we've just concluded the equation of a line passing through 1 point with gradient given. But here, we are considering equation of a line passing through 2 points. Anytime you are given 2 points, you will not be given gradient. And you'll be asked to find the equation. So how do you go about it? This is the formula we use for it. We have different types of formula, but this is the background formula. And that background formula may look cumbersome to you, and you may feel you have too much to cram as formulas in coordinate geometry, which is true. But to reduce the amount of formulae that you cram, I want to advise that instead of cramming this, but if you can cram it, it's okay. This is exactly the same thing as y minus y1 equals m into x minus x1. There's no enough time for me to prove this to you. I will prove this to you that you will see how this reduces to this. That is it. Only that this m alone means y2 minus y1 divided by x2 minus x1. You know it's gradient. And you have been taught that before now. So if you decide to be using this, it's okay for you. For you to know it's going to give you the same answer. The formula I give you originally, I will not use it. I will now use this. I will use this and you see the way I will apply it. So let's go. Example 1. Find the equation of a line through the point 1, minus 1 and negative 2, negative 13. Since you are given 2 points, it is expected of you to use the 2 points either directly in this formula, you get the equation, or you use the 2 points to get your m, the gradient. How? See what I want to do. The equation is y minus y1 equals m into x minus x1. So you understand what I'm doing. The y is this. y1 is minus 1 equals m. The m, the gradient, is what you are expected to find separately if you don't want to cram this seemingly complex formula. But if you want to cram it, it is good. If you don't want to cram it, you want to stick to this one that you have known before, then you must know that your m in this regard, your m is y2. And what is y2? y1, y2, that's minus 13, minus y1, that is minus 1, divided by x2, this x1, x2, x2, minus x1, that's just m, into x minus, what's x1? x1 is 1. And that's it. This will be y plus 1. Minus times minus is positive. So, which is equal to, minus times minus here also is positive. So, you have minus 13 plus 1 over minus 3. Minus 2 minus 1 is minus 3 into x minus 1. Y plus 1 equals minus 13 plus 1 is negative 12. Negative 12 divided by negative 3, that gives 4. Am I right? Yes, negative 12 divided by negative 3 gives positive 4 into x minus 1. So we've simplified it. You now make it y plus 1 equals, open this bracket, 4x minus 4. That is it. Restructure as y minus 4x equals minus 5. This positive 1, when you take it to the other side, becomes negative 1. Negative 4, negative 1, that's negative 5. That is the equation. But it might be left anyhow. Let's see which is like it there. A, y, if you bring this in, it will be negative 4x equals 5. No, this is negative 5. It's not correct. this is not correct as well, because y minus 4x equals 5, and this is equals minus 5. That's not correct. Option D is the correct answer. Option D is the correct answer. Why? Y minus 4x equals negative 5. If you bring the negative 5 in, it will become y minus 4x plus 5 equals 0, which is option D. So, and that is why option D is the correct answer. Let's consider example 2. Yet under equation of a line passing through 2 points. Find the equation of the line that passes through the points negative 4, 3 and 2, negative 5. 2 points. Well, let me use the original formula so that it won't look as if I don't use it at all. But I've explained to you in the first example how you can use this. Only know that your m is the gradient that you have to calculate using the 2 points. Straightforward like that. But let's use this. Y minus, what is y1? Y1 is 3 over y2, this is x1, y1, x2, y2. So y2 is minus 5 minus y1. y1 is 3 equals x minus x1. x1 is minus 4 over x2 is 2 minus x1 minus 4. So this will be y minus 3 over minus 8 equals x plus 4 over plus 6. Because minus times minus is positive. 2 plus 4 is 6. So we cross multiply there. So we have 6 into y minus 3 equals minus 8 into x plus 4. So this will be 6y minus 18 equals negative 8x negative 32. Collecting the like terms, 6y plus 8x equals negative 32 plus 18. And that is 6y plus 8x equals, if we subtract 18 from 32, what will that give us? That will give us 14, but it's going to be negative 14 in this case. Since it is negative 32 plus 18, it's going to be negative 14. 2 goes in all, so 2 to reduce this will become 3y plus 4x equals minus 7. That is it. Let's now look at the options. Which one is like it? 3y plus 4x equals 7. No, this is equal minus 7. This is far from the truth because this is 5. Yes, if we bring negative 7 in, it will become 3y plus 4x plus 7. 3y plus 4x plus 7 equals 0. Option C is our correct answer. That is 3y plus 4x plus 7 equals 0. And that is it. Option C is the correct answer. We come to another concept under coordinate geometry, which is equation of parallel lines. I call it parallel lines, but we are going to be forming equations of parallel lines. When 2 lines are parallel to each other, it is obvious that their gradients are equal. the m1 of the gradient 1 of the first equation must be equal to the gradient 2 of the second equation. That's why we write m1 is equal to m2. m1 is the gradient of the first equation, while m2 is the gradient of the second equation, and they must be equal if truly the equations are parallel to each other. Example 1. Find the equation of a line through the point this and parallel to this equation. The first thing to do is to find out the gradient of the given equation. The given equation x minus 2y equals 4 has the gradient, let's find it out, minus 2y equals 4 minus x. Dividing both sides by negative 2, so y will be equal to minus 2 plus x over 2. That is y equals 1 over 2x minus 2. It could be arranged anyhow. So the gradient here is half. m1 equals half. The gradient of this equation given to us is half because it is the coefficient of the x having made y subject of the formula. Now, let's form our equation. Therefore, the equation is, how do we form equation passing through one point? We write y minus y1 equals m into x minus x1. So y minus, what is our y1? Is this, that is 3, equals m. The m is the gradient of this equation, which must be equal to the gradient of the given equation, the parallel equation. And the gradient of that is half, meaning this also will be what? Half into x minus. What is the x1? x1 is negative 1. So y minus 3 equals x plus 1 over 2. Clearing the fraction, 2 times y is 2y minus 6 equals x plus 1. So we have 2y minus x equals 7. And that tallies with option. Which option there? It is option A. Because if we bring the positive 7 in, it will be 2y negative x negative 7 equals 0. 2y negative x negative 7 equals 0. Option A is the correct answer. Let's consider example 2. Find the value of p if the line which passes through minus 1 comma minus p and minus 2 comma 2 is parallel to the line 2y plus x 8x minus 17 equals 0. What we do is we are to find the value of p if we know that the line that passes through these 2 points is parallel to this. If the line that passes through these 2 points is parallel to this line 2y plus 8x minus 17 equals 0. What really matters there is that their gradients are the same. Isn't that the fact? Their gradients are the same. And if so, we say the gradient of these 2 points is y2 minus y1 over x2 minus x1. And it must be equal to the gradient of this line. Meanwhile, gradient of this line is, let me write it here, 2y plus 8x minus 17 equals 0. To find the gradient of this line, make y subject to the formula, which is 17 minus 8x. See what I'm doing? I take positive 8x to the other side, it becomes negative 8x. Negative 17 to the other side, it becomes positive. Dividing both sides by 2, we have y equals 17 over 2 minus 4x. Therefore, the gradient here is minus 4. And that gradient that is minus 4 here, it must be equal to the gradient here, the gradient of these 2 points. So I equate the gradient of these 2 points to minus 4. Do you understand? And what is the gradient? Y2, this y1, y2. y2, which is 2, minus y1 is minus p over x2. x2 is minus 2 minus x1. x1 is minus 1 equals minus 4. So this is 2 plus p. Minus times minus is positive. Minus 2 plus 1, that is minus 1, equals minus 4. I hope you understand what I've done there. Negative times negative is positive, so we have negative 2 plus 1, that is negative 1. I use that negative 1 to divide each of these numerator. 2 divided by negative 1, that's minus 2. Positive p divided by negative 1, that is negative p, equals negative 4. So collecting the like terms, I have minus 2. Bringing this negative 4 to this side, it becomes positive 4 equals, I take the negative p to the other side to become positive p. So negative 2 plus positive 4 is positive 2, which is equal to p. It is not a problem to write 2 equals p. It's the same thing as p equals 2. So the value of the p is 2, which is option D. Option D is the correct answer.